All right, so we are recording again. So go ahead and click the download link. You might want to just download it first and not open the zip file. Just put it somewhere. When you open the zip file, it will create a folder for you. Okay, and you just go ahead and unzip the whole thing and copy and paste everything into onto your thumb drive or someplace. Okay, I don't really. It's not important where you save the file. You just have to remember where you put it. Okay, so once you unzip the file, let me just go to the folder itself. I have already unzipped it, so I just want to show you what it looks like. It creates a folder called double1. Okay. If you don't use the command line, that's okay. You will see the double1 folder. And in the folder, you will find several files. The one file that you need to double click on once you have installed CodeBlocks is double1.cbp, which stands for Code Blocks Project. Okay? All right. So how do you get CodeBlocks installed? Because not the entire class had experience with CodeBlocks. If you are comfortable with Linux command line compiling and linking and running and debugging, that's fine. Just extract the .c files and the .h files and do it your way. Okay? Not a problem. In other words, if you're taking a class where you're using the power server to develop your programs in C and C++, you can use those tools as well. Okay? There's no need to use CodeBlocks if you already know how to use command line tools. If you do not have access to the power server, you can now go ahead and install CodeBlocks. Just search for CodeBlocks. If you search for CodeBlocks, the first link is going to the correct website, and you can skip everything and just go to downloads. When you go to downloads, you select the first one, which is download the binary release. And then the next screen looks really simple. It's not. For Windows, you don't want to download the first link. Okay, what you want is going to be the fourth link from the top, which is this one here. It says CodeBlocks, whatever the version number is, and it also says mingw, M-I-N-G-W -setup.exe. That is the one that you want. If you get the first one, it does not include GCC or GDB, the tools. If you install the fourth one, it will install the entire thing. It's a little bit bigger, but it's not by much. Is that okay? So this applies to Windows. If you're using Linux, on your own laptop, you can either use the distribution that you're used to. Debian has CodeBlocks. Ubuntu has CodeBlocks, so you can just use whatever comes with the distribution. Just install CodeBlocks. If you use a Mac
doesn't open up CodeBlock projects. I'm in like 430 and I can't use a MacBook.
Okay, so with a Mac, there's an older version of CodeBlocks, which is version 13 instead of 17. Yeah. I'm not sure whether it will open it or not. It does not. Okay, that's because there are not enough people using the Mac with CodeBlocks, and because Macs have Xcode, which comes with its own IDE. So for you can use Xcode if you want to, and just re-import the source files. That works too.
Yeah, that's right.
Yeah, because I don't need you to turn in the CodeBlocks project file. So there's no need to worry if you cannot use the project file. Okay? All right, so assuming you have CodeBlocks installed, and all of these computers have CodeBlocks already installed, so you should be able to open the project. Then you go to the project, you go to CodeBlocks. This is the way I go to CodeBlocks. The way you do it in Windows is different, obviously. And this one is only 16.01, so I'm using a slightly older version of CodeBlocks, not the latest and greatest, but that's okay. So what you do is you go to File, you click Open, you navigate to whatever folder you unzip the double1.zip into, and in that folder you will find the file that ends with CBP as the extension. And here's the tricky part. If you do this in Windows, you may not be able to see the extension because Windows by default is hiding extensions of files, which is extremely annoying to me. So do whatever you need to find out which one is the .cbp file and open that one. Okay. So once you have that one, you click Open, And that's your project. So the first thing you might want to do is to look under sources. There are 3 files to this particular project because I like to separate my functions and put functions into different files depending on what they do. You don't have to do a single thing about main or parse, okay? So don't make any changes to those particular files because you don't really need to. Your code is going to be in exp10 to 2. You're changing from exponent 10 to exponent 2, and that's why the name of that particular file. In this file, I'm already in that file, there's a single function called exponent 10 to exponent 2, and it expects a pointer to a particular structure, and your code has to go into this particular function. You cannot change the parameters. You have to use the parameters as is. The parameters or the structure itself is defined in a .c file, so you can go to number.h. This particular .h file includes the structure definition, so that you know what components are inside the structure. It has got the usual things, okay, the stuff that we have talked about in class. It has got the mantissa, it's got the exponent 10 and exponent 2. The mantissa itself is a 64-bit unsigned integer. The 2 exponents are signed integers. So are we doing okay so far with this? Okay. Next, how do you run this program? And how do you check whether your code is working or not? First thing, you go to project, and then you go to set programs arguments. And then you want to make sure that your program arguments, which is over here for debug, looks like this. -n space, and then you just input whatever number you want to use for testing. It can be the number that your student ID correspond to if you are adventurous, but I would pick something that's easy first. Okay? When I say something that's easy, it means something that has a very easy representation in floating point representation. Okay? I'll give you one example. 1.25 e minus 1. So what is 1.25 times 10 to the power of -1? Why is that easy?
Because it's a power of 2.
It's a power of 2. Which power of 2 are we talking about?
To the power -3.
-3, that is correct. Okay. So this is a good one to use because it is a very easy power of 2 to deal with. So we just click OK. So once you have set up the parameters, you can run the program. But this program does not have standard in and standard out at all. There's no input or output. So the way you do it is you have to set up a breakpoint at the right point in the execution of the program. So if I just want to examine what PN is pointing to at this point, I just put a breakpoint on line 11. And the way you put a breakpoint in CodeBlocks is to do a click right next to the number, just a little bit to the right-hand side, like that. Okay. When you see the little stop sign, it looks like a red circle, when you're too far away, but it's actually a little stop sign. When you see the stop sign, that means when execution reaches that line, it will pause, and then you have a chance to examine the variables and other expressions. Is that okay? All right. Okay, so now we are ready to run this program. Even though it doesn't do a single thing, we can still check out what PN is pointing to. So you go to debug, okay, and then you just click start/continue. If you have made recent changes to the program, CodeBlocks knows how to recompile the whole thing and bring everything up to date. So you just run the whole thing, and here we go. So when you see a yellow triangle or pointer or arrow, that means execution has stopped on that particular line before that line executes. Okay. So right now execution has stopped. The program is paused, and I can now use GDB to examine certain things. You're more than welcome to use the GUI, like highlight something, and then right click, and then say watch that particular thing. But I personally prefer to use the command line. So I can go to command, which is at the bottom here. It is under the debugger tab of logs and other, okay? If you need this window to be larger or smaller, you can drag it up and down so you can make it smaller or make it longer or shorter depending on how you like it. So now I can say print, okay? All the commands that we talked about in class can work here. Okay, so you can, because this is really just a direct interface to GDB, so we are actually using GDB in the back end. So you can print, say 123, okay? It prints 123, not very surprising. But you can also print, PN. PN is a pointer. So by saying print PN, it doesn't really tell you something that's useful, because all it's going to tell you is the structure is located at memory location 7FFF, FFF, FFF E740, which is not relevant to what we're trying to do. What you want to do is to print dereference PN, because PN is a pointer to a structure, so when you dereference it, it becomes the structure. And the nice thing about GDB is when you dereference a pointer to a structure, it doesn't just print that, oh, this is a structure. It actually tells you what each member is inside the structure. So in one single print, you can now see that member sign is a 0 because the number is not negative. Mantissa is 125. It's 125, not 1.25. The exponent of 10 is not -1 anymore. It is -3. That is because when you multiply Mantissa, which is 125, to 10 to the power of -3, it is the same thing as 1.25 times 10 to the power of -1. Is that okay? So my parser automatically converts the Mantissa from whatever point or fractional representation to a full integer. But it also automatically adjusts the exponent of 10 to take care of shifting that decimal point. Is that okay? Do we have any questions at this point? Nope? Okay. So your job is to change Mantissa, EXP10 and EXP2 so that we are maintaining the value being represented, but we want to turn EXP10 to 0. We want to maximize Mantissa so that bit 63 is a 1. And your flexibility is to keep modifying EXP2 so that the other constraints are satisfied. Are we okay so far with what your program is supposed to do? Let's take this example, okay? So if this is presented as the input, what do you think is going to be the Mantissa when we're all done? I want the Mantissa to have bit 63 turned on, to be a 1. But I have the flexibility to play with EXP2. So what do you think is going to be the 64-bit unsigned number as our Mantissa? Okay, let me switch back to the notes. Yep, you got it. So let me switch back to the notes because the constraint is also represented here. So the value that we want to represent is whatever the Mantissa is. The Mantissa has to be an unsigned 64-bit integer times 2 to the power of some EXP2 times 10 to the some power of EXP10. So we are gradually trying to increment EXP10 to 0. But by doing that, we are also going to have to adjust EXP2 downwards, okay? And Mantissa needs to be as large as an integer as possible that can still fit in a 64-bit unsigned integer. Those are the constraints. Is that okay? So now getting back to this particular example, what do you think Mantissa should be in order for it to be the largest 64-bit unsigned integer? We can play with the magnitude later on. Remember, we can play with the EXP2. What about this?
Wouldn't it just be a -1?
Huh?
Wouldn't it just
No,
be
no, no, because it's unsigned. There's no negative.
unsigned?
Yep, it is unsigned. So Mantissa is an unsigned 64-bit integer. So how do you represent 1/8? But I want the quantity to be as large as possible. So how do you represent 1/8?
1,
Followed by
63 zeros.
Yep, exactly. So we want Mantissa to be 1 followed by 63 zeros because that's the smallest value you can use for Mantissa. Okay, that's one of the constraints of the homework assignment. You have to make your Mantissa, between 2 to the power of 63 and 2 to the power of 64, the whole thing minus 1. You have to make Mantissa fit into that range. Is that okay? All right, so let me work this out in mousepad. Okay, I'm gonna get rid of all this stuff from the previous class. Okay, so I want Mantissa to be 1 followed by 63 zeros. Okay, so in hexadecimal, it's much easier to look at these in hexadecimal. It's 8 followed by 15 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Why do you think this in hexadecimal is going to specify 1 followed by 63 zeros in binary?
Because the first one is 4 bits, and to represent 8, it's just a 1, 0, 0, 0.
That's correct. Every hexadecimal digit represents 4 bits. The hexadecimal digit 8 is representing 1, 0, 0, 0. Now, 0 obviously is going to be representing 0, 0, 0, 0. So this one here is representing the most significant bit being a 1, and then the other 3 bits are zeros. And then these guys are basically specifying 60 additional zeros to the right-hand side. So are we doing okay so far? Okay. But we can also look at this as just 2 to the power of 63, right? So if Mantissa is this, what do I need to be in EXP2 so that the value represented by Mantissa times 2 to the power of EXP2 is still 1/8? What is 1/8? 2 to the power of
Negative 3.
-3. So our EXP2 has to be
Negative 66.
Yep, there we go. And at the same time, EXP10 should be 0 because there should be no component of exponent of 10 anymore.
Are you recording right now?
Yes, I hope so.
Yes.
I'm pretty sure I am. Yep, we're streaming and the audio is up. But are you guys convinced that if I multiply this Mantissa to 2 to the power of -66, it's really the same thing as just 1/8? No, so this is the correct answer given that being the input. Are we doing okay, or do we want to? Are there any questions at this point?
So for the homework, you want us to output the Mantissa in hex or binary?
You can use either one, as long as if you prefix the hexadecimal with 0x, I understand then it is a base 16 number. So that's all I need is for you to indicate is it base 10 or base 16.
And then you want us to put however the exponent value is. And
Yes, EXP2 has to be stated. EXP10 is assumed 0.
okay.
Yep.
And are you going to be putting in the inputs, or where are we getting the inputs from?
The input, you can test your input based on the spreadsheet. So if my student ID is 1, 2, 3, 4, 5, 6, 7, then this is the one that I need to use to turn in, quote unquote, the answer. But when you're testing your program, I would strongly advise not to use this to test your program, but instead use something that is easy to test and easy to visualize, like 1.25 times 10 to the power of -1. Is that okay? Yep, go ahead.
So you're saying that's the number to test, and then our expected output is what?
I'm not going to tell you what the expected output is because that's what I'm asking. But if you want to check whether your expected whether you have the right answer, you can email that to me and I can tell you.
Okay.
Okay? So the quick way to test whether it is in the right ballpark or not is to do this on the calculator. Okay? So on the calculator, whatever your mantissa turns out to be, okay, multiply that to 2 to the power of exp2, like that. If that value is close to the base 10 representation that you're given with, then you're in the right ballpark. Then you might still have rounding errors, but you cannot be that wrong from the actual answer. Okay, so you do have a quick way to kind of, quickly check whether your approach in general is correct or not. But tiny little errors, may not show because of this.
So you want the mantissa and then the exponent of 2.
Yes.
Okay.
Yep. Those two would be a part of your answer. Yep.
And you want that to be put into the spreadsheet? Or
Nope.
You want that
It
to
is
be
just-
on a file or an output? Or
No. If you scroll all the way to the end of this, there's a little open editor area. So you just, put it here. Just state, this is the mantissa. Okay.
Oh, okay.
So you just specify, what you think should be the mantissa and what you think should be the exponent of 2. That's it. So this one, I do have to grade by hand. I tried my best to try to program Canvas to do this. There's no way I can program Canvas to do this. Yep, so this one is going to take me a little bit of time to grade. Any other questions? Pick me. Where do I read about this stuff? I'm so glad you asked. Okay, so all of this stuff is in the module that talks about floating point numbers, particularly the section that talks about how to do the conversion. So if you go to floating point number representation, this particular module talks about how a double precision floating point number is and how it represents a value. But when you get down to moving on, section 5, it talks about how to do a conversion from base 10 to the double representation. Your homework is not all the way to double. Your homework is only taking you halfway through the whole process, and it's only one half of the half, because we only have to deal with negative exponents of 10, not positive exponents of 10. So the bottom line is we want to keep going, okay, getting rid of the exponent of 10, and specifically what you are dealing with is when the exponent of 10 is less than 0. So you should focus mostly on section 5.2.1. Okay? But there's other stuff before this that is helpful, like how we do rounding in the division. So that is still going to be helpful. So you can probably already see how the previous 2 labs are really there to set up to help you out with this, because the labs talk about the concepts and you can use a calculator to do most of the math. This time you have to use your actual C code to do it. So the approach is try to make M, or mantissa, as large as possible, but it is still smaller than, okay, make this as large as possible, but do not overflow what you can represent using a 64-bit number. So that's the first question. How do you do it? How do you do it that way? We know how to do this part, right? We just don't know when to stop doing it. So when do you stop? What is a good indicator that, yep, I think we got it, time to stop? How do you know that M is between 2 to the power of 63 and 2 to the power of 64 minus 1?
Use the bitwise and.
You can do a bitwise AND, but if you don't know bitwise AND because your C and C++ professor never mentioned anything about bitwise operators, then what do?
Oh, it just means that it uses
Comparison, right?
Yeah.
You can always compare. But then how do you know what is 2 to the power of 63? Well, I just showed you one. What about 2 to the power of 64 minus 1? What would that look like?
all ones.
In binary, it'll be all ones. In hexadecimal, it's going to be all F's. Exactly, because F is 1, 1, 1, 1. Okay? So you just have to do the compare. Okay? Make sure the M is less than 2 to the power of 63. If it is less than, double it. And every time you double it, you have to adjust the exponent of 2. Because when you double the mantissa, in order to maintain the value, you have to adjust the exponent in base 2. Is that making any sense? Do we know how to perform each step and when to stop this loop? Okay. So when you get out of this loop, you already have a number that is as large as it can get. Okay? Then you can do the division. The division is like this, okay, except you don't have a floor function, do you? Do you need a floor function?
No.
Exactly. You do not need a floor function because integer division in C is automatically truncating. And for non-negative numbers, truncating is just as good as floor. Okay? So every time you do a division by 10 to the mantissa, you have to adjust the exponent in base 10. So the base 10 exponent is supposed to be negative to begin with, so you're taking it one step closer to 0. So are we doing okay so far with this? Okay? So just keep doing these things. So this is a loop by itself. When you get out of this loop, do these 2 steps. This entire thing is in its own loop. So keep doing that until E10 is 0.
I just said nested loop.
Yeah, we have a nested loop structure here. That is correct. Okay? But don't forget the answer, okay? The expected answer is mantissa has to be the largest value that can still fit in a 64-bit number. So when you get out of this loop, okay, when you're done with this, M is as large as it possibly can. But once you do this, it's not as large as it possibly can anymore. So keep that in mind, okay? You might need to put this loop after the main loop or turn it into a subroutine. Is that okay? So do we know what to do with this homework assignment?
Yes.
Cool, excellent. How about the setup of the tools? Does everybody has a particular platform where you can compile plain C programs and have a debugging environment?
Oh, you want this in C or C++?
Well, my code is in C, so you don't really have a choice.
Isn't the prereq C++?
Huh?
Isn't the prereq C++?
Say that one more time.
Isn't the prereq for this class C++, not C?
Yes, but C++ is a superset of C, which means if you know C++, you already know C.
For the most part. They have different ways of doing it.
And it's also a proper subset too, in case you're also in CI SP440. You don't really need to use any C++ feature. I don't really see the need to use C++. Plain C is more than enough.
We don't know what C is. Like there's like other than the print function, there's certain ways that C++ can compile things different than C.
But we're not printing anything. The program has no reading, has no writing. There's no file operation of any kind. So you can only tell whether your program is working or not using a debugger. You cannot do this homework assignment without a debugger. which is kind of the point. I want to make sure everybody knows how to use a debugger. Are there any questions? Well, okay. Let me rephrase that. Are there any questions before I turn off the recorder? No? Okay. Can we do this in a week? Okay. Cool. I'm going to turn off the recorder. And if you have questions, go ahead and raise your hand and I will come